Greetings and welcome to the Plsql channel, a series of video trainings on the Oracle Plsql language. My name is Stephen Feuerstein, and I'm a Plsql developer just like you. This lesson is part of my series on error management in Oracle Plsql, and the focus of this lesson is handling exceptions. Some quick reminders. If you haven't already done so, visit Plsql Obsession at toadworld.com/sf, and you can access both the code that supports and complements this presentation, along with PowerPoint documents that you can use to further enhance your training on the Plsql language. In addition, make sure you're comfortable with the material covered in the previous lessons in this series, most specifically defining exceptions and raising exceptions. However, in this video we're going to talk about handling exceptions, and I'll start by talking about when to handle exceptions. We'll move on to what you should do inside an exception handler, and most of the session will be focused on Oracle built-in functions that give you lots of information about your error and the error situation. You can get the error code with the SQL code function, SQL error message to retrieve the error message, and then there are several more critical and useful DBMS utility functions that give you the execution call stack, the error stack, which is another form of the error message, and the backtrace, which means the line on which the error was raised. So we'll look at each of those in a lot of detail. But first of all, I'd like to take a step back and just talk about what should happen in an exception handler, when you should have them. So, when to handle exceptions. So Oracle provides a separate exception section that consolidates all the error handling logic in a single block. And of course, any complex application will have multiply nested blocks. A procedure calls a function, calls a procedure that has a nested block that calls another procedure. And each one of these subprograms and blocks are their own Plsql blocks, and each one can have their own exception section. So as we write our code, as we write all these individual programs, we need to decide, should every block have an exception section? Should I just let the exception propagate to the top level block for handling? Should I let exceptions go unhandled to the user? And there's actually no single right or wrong answer to each of these questions. It mostly depends on what kind of information you need to provide to your users and to record for your support team and your developers to fix problems that occur. Now, certainly generally I would argue that you shouldn't allow unhandled exceptions to propagate out to users. There's really no reason to allow that to happen anymore, though there was an argument for it prior to Oracle 10G. But if you're going to trap your exceptions and not let them propagate out, you still have the question of when to do it, at what level to do it. Let's take a closer look. Because what's really the core question is what information has to be captured. Now, usually when an error occurs, we want to figure out why the error occurred, and therefore we need to capture as much information as possible about the cause of the error. Now, Oracle does give us a number of built-in functions that allow us to grab that information or grab some of that information and log it, pass it back. But a lot of critical data has to do with the variables in our own application, not things that Oracle generally has access to or will record for us. So if we want to get information about what's going on in the specific block in which the error was raised, generally speaking, you need to handle the exception in that scope, in the scope in which that information is still available. So my usual recommendation is to trap exceptions in the block in which they were raised. In other words, generally speaking, lots and lots of your different subprograms, your nested blocks, would have their own exception section. Let's take a look at this process a bit more closely. So I'll open up the info for handling script. This is available in your demo zip, which you can download from toadworld.com/sf, Plsql Obsession. So I've created a procedure called handle locally. I pass in a value, and the value will be 1 or 2. And then I have an outer variable, a variable declared at the procedure level called outer, and assign the value of 1. Then inside my procedure I have a nested block. And in that nested block I have a local variable whose scope is existing only in that nested block. And if my parameter coming in is 1, I'm going to raise no data found. Otherwise, I'll raise value error. Now, if no data found is raised, the exception is trapped locally in that same block. And I raise an application error, passing it the -20,000 error code, and specifying this message. In other words, I'm going to grab the value of the inner variable. If value error is raised, this exception handler will not trap the exception. It will come out unhandled. This entire block ends with an exception, which forces the outer block to also terminate with an exception. The when others clause will trap that error, and then it in turn will raise application error minus 20,000 and display the outer value, or pass the outer value back as a part of the error message. So let's see what happens when I call this program for handle locally 1 and handle locally 2. So with handle locally 1, what you can see here is that the first raised application error, let's bring that text back. The first raised application error that was executed because the no data found was trapped recorded this message for the error message and then propagated out the minus 20,000 error. So notice we can see the value of the inner value variable. And then it's propagated out, and we then see the outer message as well. So outer value equals 1. So notice that because we trapped the exception inside this nested block, I was able to access the value of this inner variable. When I pass the value of 2, and the exception is not handled locally, then it only has access to the outer value, which is what is displayed and propagated out here. And just to drive that point home, if I did try to get the inner value, suppose I wanted the outer value and the inner value, so let's concatenate these together. So I've got outer value and inner value. Well, what's going to happen here is that when I try to create the procedure, I'm going to get an error. Linner must be declared clearly, as I'm sure a lot of you could instantly see. Linner is only defined in the inner scope, not the outer scope, and therefore I have no access to it in that outer section. So this simply drives home the point that when an exception is raised, if you need to record any of the information about variables declared in the scope of that block, you've got to have an exception section on that block, whether it's a nested block or simply for the procedure as a whole. And then you can record the values, whether you stick them in the error messages, which I've done here, which is a fairly crude mechanism, or you log them out to your error logging tables. You will not be able to get that information unless you trap locally. So that's the strongest argument I know of to attach an exception section to virtually every single one of your subprograms and your blocks to make sure you can record the maximum amount of information. Let's head back to the PowerPoint. So I've clarified what I think are the best requirements or the best guidelines for when to handle exceptions, and that is handle them in every single block in which you have critical information that needs to be grabbed and recorded and possibly sent back to the customer, the user. Then the next question is, what should you do in an exception handler? So the exception was raised, you trapped it with your when clause, you've got it. Now what do you do with it? Well, in general, you need to decide and answer the following questions. Do you want to record the error information, and where should you do it? Usually what you'll do is write the information out to a log table or an error table. You need to decide what information you want to record. Clearly, as I just mentioned before, that if there are local variables that played a critical role in the error, you're going to want to record that value. And finally, should you re-raise the exception or raise a different exception after the information is logged? So if the error occurred, you have to decide, is this a critical error that needs to be propagated out to stop all the enclosing blocks, or is it an error that really is not that critical to cause the stoppage of the application? Now, once again, there's no right or wrong answer to these questions. You get to decide pretty much on an application and program basis. But I think it is very important that you sit down as a team before you start writing your next application or the next big effort in your current application, and set some standards that reflect answers to these questions. So decide as a group what kind of information you want to record. What are the conditions under which you would re-raise an exception, force the exception to propagate out? How and where are you going to record that information? And I'll be talking more about this in my separate video on best practices for error management and creating and using a single shared utility that will handle lots of this for you. Okay, so let's move on to focus on the built-in functions that Oracle provides that will help you handle exceptions, and grab the information you need to then debug and assess your situation and fix it. So in addition to all the application-specific information you might want to log, your variable values, the state of your tables, etc., Oracle built-ins will provide you with answers to the following questions. How did I get here in my code? What was the execution call stack, the sequence, A called B called C? What is the error code? So in other words, what error occurred? What is the error message? Also the error stack. We're going to talk about the difference between the error message and the error stack. And on what line was the error raised? A really critical piece of information that was made available only as recently as Oracle 10G Release 2. So first of all, the classic functions that have been around forever that I'm sure you all know about, SQL code and SQL error message. SQL code returns the error code of the most recently raised exception in your session. So if it's a no data found, it might be an ORA 1043, it might be a -1 for a do file index. It's the error code. SQL error message returns the error message associated with SQL code. In other words, it's commonly used to return the error message of the current error, but it also is a generic error message lookup function. Neither SQL code nor SQL error message can be called from within the SQL statement. For example, if I'm doing insert into a log table, you can't include calls to these functions inside SQL. You have to assign them to local variables and then use those values, the variables, in the actual SQL statement. Let's take a look at SQL code. So just to demonstrate what I mentioned about not being able to reference SQL code inside the insert statement itself, if I try to run this code, inserting my SQL code into my log table, Oracle says, not acceptable. Column is not allowed here. I don't really know why they've decided you can't do that, but you can't. So what I would have to do is assign that SQL code value to a variable and then do that. And then do an insert with that. So we'll run it this way. And a row has been inserted into my table. Okay, not all that interesting really. Now let's take a look at a little bit more of the nuances of SQL code. So I've put together a script that calls SQL code under a number of different circumstances. So let's go down to the bottom of this section of code. Here's my main body of code. And I'm going to call SQL code first of all at the very start of my program. So there's no exception. I've just started running my code. What is the SQL code value? Then I'm going to raise no data found and immediately trap it inside my exception section. So we'll take a look at SQL code immediately after I've trapped the exception. And then I'm going to call a local insert procedure. So local insert does an insert into my table, and I'll look at the value of SQL code before and after. Then I'm going to delete from the table, and we'll take a look at the values of SQL code before and after that as well. Raise 20,000 will raise the -20,000 exception. I'll trap the exception, and we'll take a look at the SQL code then. And then finally, after we're done handling the exception, we'll take a look at SQL code. So I run my script. And here's what I see. First of all, at the very beginning of my block of code, when I call SQL code, it returns 0. 0 means no problem, there's no error. And if you ever execute SQL code outside of an exception section, either explicitly within the exception or within a program that is called from the exception section, if you're not in the midst of an error, SQL code returns 0. Okay, so then I raise no data found, trap the exception, I look at the value of SQL code, it's now 100. That's the error code for no data found. Actually, no data found is a kind of curious exception in Oracle. It's associated with two different numbers, 100 and -1403. So if you look at the error message, you'll see -1403, but the SQL code is 100. Rather odd. Then I perform my insert. So I check SQL code again, do the insert, check it afterwards, and notice it stays at 100. In other words, this procedure is not inside the exception section itself, but it's being called from within the exception section. Therefore, SQL code has been set to a non-zero value, and it shows that value throughout every single reference to it while it's being called from within the exception section. Then I come out of that program, it's still 100. It's still 100 after I delete. And then I call raise 20,000. Raise 20,000 checks the value of SQL code. It's still 100. Then it raises the negative 20,000 error. In other words, it calls raise application error, which means that it substitutes minus 20,000 for the SQL code value. And therefore, when I trap the exception and display SQL code, now it's set to minus 20,000. Then I come back out after local proc raising of minus 20,000, and notice this, SQL code is back to 100 because I'm no longer within the exception handler in which the current error was minus 20,000. I've propagated back out to the other exception section in which the SQL code is 100. So it actually has a stack of error codes that it keeps track of, and it's set back to 100. And then when I come out of my exception handler back to the main body of code, SQL code is set back to 0. So things to remember, SQL code is always 0 when an exception is not in the process of being handled or raised. The SQL code value will vary depending on the scope. In other words, in my inner scope, if another exception is raised, inside that scope, the error code is whatever that error was raised. But if I terminate that exception without re-raising an exception, that means I come back to my outer exception handler right here. The negative 20,000 error is no longer valid. It's no longer present because I didn't re-raise the exception. So we're back to the original exception, 100. So that's SQL code. Let's now take a look at SQL error message. SQL error message has been used for years to display the current error message. But if you don't pass an argument, and that's if you don't pass an argument to SQL error message, if you simply call the function, then it returns the error message for the SQL code value. But you can also pass an error code to the SQL error message function, and it'll look up and return the generic error message for that number. And then we get into some complications around the length of the error message that will be displayed. It turns out that in the current versions of Oracle, Oracle 10 and higher, the maximum size of the string returned by SQL error message is 512 bytes. Please don't ask me why. I do not understand why Oracle puts in these kinds of limitations, but they do. And it turns out that when the error message is returning a stack of errors, and we'll explore that in just a moment, a single error message versus a stack of errors, it's actually possible that Oracle may truncate your error information. So as a result, Oracle recommends that you don't use SQL error message to display or retrieve the error message. Instead, use its new replacement, DBMS Utility format error stack, which we'll explore in just a moment. As to why Oracle didn't just say, let's expand the size of the string returned by SQL error message and not have to give you a separate program, I do not know. But that's the way it is. So let's take a look at some of the nuances of SQL error message. So I'm going to create a program or a table called Pilch Parts. That's for the Plsql Challenge, a website that offers daily quizzes. And then in my declaration, in my block of code, I'm going to declare my own exception. And then I'm going to call SQL error message a number of times. So I'm going to pass it negative 1855, and we'll see what it returns. I'll pass it positive 1855. I'll pass it 0 and pass it 1. Then I'll try to insert into my parts table for a row that has a part name that is too big. It should raise an exception. And then we'll see what information is displayed here. So let's run through these different steps. Let's see what we get. Okay, so if I pass SQL error message negative 1855, then Oracle returns that error message, the Oracle error number plus the message. That is a valid Oracle error related to date format masks. If I pass it a positive 1855, Oracle says, I don't know what you're talking about. That's a non-Oracle exception. So pretty clearly, from Oracle's perspective here, error numbers are negative. And I point this out because in other aspects of error management, it turns out that Oracle decides to treat error codes as positives and not negatives. They're very inconsistent, which is unfortunate. But certainly from the SQL error message function standpoint, Oracle codes should be negative. If I pass it as 0, that means there's no error, and Oracle says it's a normal successful completion. If I pass it a 1, which is the error code for a user-defined exception, then you see user-defined exception. A very uninteresting error message. Then I try to do an insert into the parts table. I pass it a string that is too large, and Oracle raises the -12899. So here's the SQL code, and here's the SQL error message. And notice it displays all the specific information, the column name that the error occurred on, the actual and maximum sizes. And I can also pass the SQL code. And it also shows me that full set of information. So those are some variations about how SQL error message works. Let's run it again now. And instead I'm going to raise my own exception. So don't worry about any of this stuff. I've declared an exception. I raise it. Let's see what I get. Notice the error code is 1, and the error message is user-defined exception. And that's why whenever you declare your own exceptions, you should use a pragma exception init. The pragma exception init allows you to associate an exception with a number, like -20,100. And if I do this, then when I run my code, whoops, encountered the symbol. I lost my semicolon. Okay, let's do that again. And now I see that my error is -20,100, and there's no error message because I didn't provide one through raise application error. But at least I was able to change my error number from 1, which is very generic, to whatever error number I want. Now let's reopen this file one more time. And let's run this last block of code in which I try to insert into my table, and I try to use an index value or a primary key that's already used. Let's see what I get this time. And here's the -1. So notice it says that I had a dupe val and index error. That's the -1 value. Looked up the unique constraint error message, shows me the name of the constraint, and so on. So in general, developers are used to using the SQL error message function like it's shown here as to return the error message for the currently raised error. And as I will talk about when we look at DBMS Utility format error stack, Oracle says don't do that anymore. Use the format error stack instead. But you can also use the SQL error message to look up error messages for specific Oracle error codes. And you can see an example of that in the continuing past exceptions with for all and save exceptions video, when we actually look up the error message from the error code that Oracle saves in the process of executing a for all statement. Back to PowerPoint. So let's take a look at the DBMS Utility error functions. First of all, we can answer the question with how did I get here by calling DBMS Utility format call stack. We can answer the question what error occurred, what was the error message, or more generally the error stack with DBMS Utility format error stack. And most importantly, we can find the line number on which an error was raised by calling DBMS Utility format error backtrace. So format call stack. So the call stack reveals the path taken through your application code to get to that point. A calls B calls C, or maybe C called D calls C. There are many different ways that code will navigate through your stack of programs. This program is really critical to use whenever you're tracing or when you're logging errors. So if I want to basically do a trace to say, well, here's the value that's in my code right now, and I might very well want to know, how did I get there? I might have taken the wrong path or a path differently than I expected. And the string is formatted, which is why it's called format call stack, to show the line number and the program unit name. But it unfortunately does not show the names of subprograms in packages. It's not quite perfect, or at least it doesn't quite give me everything I'd love to see. Let's take a look. So in my script, I have a procedure called proc1, and proc1 calls format call stack. And format call stack will then be displayed. And what I've also done here is add another piece of code that takes advantage of another program called OWA Util, which you may have heard of. It's called Who Called Me. This is a package that was added to support HTTP or web-based development for Plsql. And as you're about to see, it offers very similar information. In fact, let's just comment it out for the first round, and then we'll go back and run it so we don't confuse things. So proc1 will call stack and display it. Package1 has proc2 in it. Proc2 calls proc1, and proc3 calls proc2, and then we'll call proc3. So I run my code, and here's the call stack. Again, it's called a formatted call stack because Oracle formats it for us. It provides the object handle, which I think is only of interest to Oracle. I've never found a use for it. It shows me the line number that it was executing within whatever the program unit is. And it shows me the stack. The bottom of the stack is always an anonymous block because Plsql is an embedded language. Then proc3 is called. Proc3 calls proc2, but notice there's no proc2. There's just package1. And then proc2 or package1 calls proc1, and it shows me the program unit type, the owner, and the name of the program unit. So this is great. This allows me to follow the path of execution through my code. And again, critical whenever you're tracing execution or when you're logging errors. So the only problem I have with it is that it doesn't tell me that I was running proc2. That's what it should show me. And the problem is that when Oracle compiles my packages, all the names of the subprograms are replaced with pointers. At runtime, Oracle literally doesn't know the name of these subprograms anymore. So we have to take this line of code, go to our all source data dictionary view, or of course go to our schema browser, go to that package and look up what line 6 is. Then we can find out the name of the program that we were running. But the bottom line is that we do have the full trace of information showing the path through our code. Now let's do it again, and instead of running DBMS output, instead of running format call stack, let's go ahead and try out this OWA util, who called me. I run this code. And here's what I see. Who called me? And it's HR package1 line 6. In other words, OWA util doesn't have access to any more information that we have from the call stack. In fact, I'm quite certain that this program really just calls format call stack and parses the string that's returned. So there's no additional information. It doesn't, for example, say, I was actually hoping it would, say proc2.6. Now, if you're interested in actually parsing the call stack, you can if you want to. I've got a package that will do it for you, the call stack package. And it basically will, you pass it the call stack, or it's called for you, and then it does the parsing necessary to plot the most recent entry. I never use it, though. I spent a fair amount of time writing it. But what I do instead is simply call the call stack function and write the value out to some table, my logging table or my tracing table, and then I look at it later. But if you want to do some parsing, this package should give you everything you need. So that's call stack, answering the question, how did I get here? Now let's take a look at format error stack. So this is the program that Oracle says you should use instead of SQL error message. And it returns the error stack in the current session. And the reason it's called format error stack is that it's possible under some circumstances to have more than one error message being returned. It returns null when there's no error, so it's different from SQL error message in that way. It also doesn't look up an error message for an error code like SQL error message does. It's much more focused in its purpose and its functionality. And it returns a string of a maximum size of 2,000 bytes, at least according to the documentation. So again, for some reason, Oracle has decided to limit the amount of characters we can pass back in our format stack. I'm not sure why they bother doing that, but they do. And Oracle recommends that because at least there's more bytes of data returned, 2,000 instead of 512, that you use this function instead of SQL error message to reduce the chance of truncation. So let's take a look at the error stack program and the idea of a stack, and then we'll take a look at the truncation issue that could occur. All right, so in this file, what I've done is create a separate procedure called show errors that will show me the contents of format error stack, and then we can compare that with SQL error message. And I have proc1 that raises no data found, and then my package proc2 calls proc1, traps the exception, and raises dupe val and index so it changes from one exception to another. Proc3 calls proc2, traps any exception that might have been raised, and then in turn calls raise application error to raise out or propagate out a minus 20,000. And the third argument here, which is not often seen on raise application error, is called keep error stack. And the question is, do I want to keep the error stack or not? And I will keep it here so you can see the impact of an error stack. I'll call proc3 and we'll show the errors. I run my code and here's what I see. So the error stack really does exist, and here it is. We start with no data found. No data found then turns into the dupe valin index, which in turn turns into the minus 20,000. So for each one of those steps along the way, from no data found to dupe valin index to minus 20,000, because I said keep the error stack here, the error stack becomes visible, and as you can see, the error message as a result can get quite long. And if I change this to SQL error message instead of format error stack, and run this code, you see in this case exactly the same thing. So format error stack and SQL error message in many circumstances will return the same string. But again, and as I'm about to show you with a separate script, you can run into truncation problems with SQL error message, and you're much less likely to run into them with format error stack. Now let's see what happens when I turn off the error stack. So if I don't pass true but instead pass false. So I'll recreate proc3. I'll say don't pass the error stack and then run proc3 and we'll see what I get. And the answer is I just get the message. So there's the topmost error message. That's with SQL error message. And if I go back and also recompile this one so I show the format error stack instead and run it again, I see just the top level error message. So you can turn off the stack and just see the top level error message. But if you do want to see that full stack, you're definitely much better off using format error stack. So let's now take a look at the truncation issue. Here's a procedure that will show my errors, both SQL error message, the length of SQL error message and the string, and the length of the format error stack and the format error stack. And I've created a program called raise error, which is recursive. It calls itself 100 times, and then it propagates out exceptions through 100 calls. So I run this code, and I'll get a very big error stack. And what you'll see here is that SQL error message has been truncated at 510. Here's the error stack, and notice it's truncated. Format error stack has the full 1297 characters, and there's no truncation. Now, as I mentioned before, you will hit truncation at 2000 and maybe even a little bit before. I don't remember the exact number, but it's often not what Oracle says in the documentation. But the chance of you running into a truncation error with 2000 characters and format error stack is pretty darn low. So I don't think you have to worry much about that. And I would, as a general rule of thumb, get into the routine of not using SQL error message and instead use format error stack. Now you might say, Stephen, please, seriously? Look at this. Look at all the code I have to type to say, just get my error message. And I agree with you. It's a real pain in the neck that they have these very long program names. Here's what I do. I take advantage of templates in Oracle, or in Toad. So I might say I want to log my error, log error, and I'll write FES, format error stack, control space, and there it is. And I don't have to write it over and over and over again. So if that looks good to you, what you can do is simply highlight and copy to clipboard, right click, editor options, code templates, add a new template. I use format error stack, and then you can put in your code. I've already used that one, obviously. Let's do FES1. Put in your code. OK. And that's done. And now I can type FES1, control space, and there it is. So if you ever find yourself being frustrated by having to do all this typing, the same thing over and over and over again, use your IDE to the fullest possible. Use the templating and the snippets to save yourself lots of time and hopefully save you from carpal tunnel. Okay, finally, let's talk about DBMS Utility Format Backtrace. Definitely the most important of these different functions. The backtrace function, which is new to Oracle 10G Release 2, answers the question, where was my error raised? On what line of my code did the error come from? Prior to 10.2, it's hard to believe, but it's true. Prior to 10.2, you could not get this information from within Plsql. The only way to see that trace back to the line number was to let your exception go unhandled. Remember back at the beginning of this video, I talked about the question of when should you handle exceptions. Maybe you should let your exceptions go unhandled out of your backend entirely to the users. And I've actually talked to developers who set as their standard in their organization that they will never trap any exceptions in their backend code. All exceptions go unhandled to the user. And they would train their users to read the trace and tell the support team the line number on which the error was raised. That's really horrible, and it's no longer necessary. In 10.2 and higher, you can now trap the exception internally and call the format backtrace to get that information. And I strongly suggest that whenever you log an error, you call the backtrace function and throw that trace information into your log table. And also note, and we'll look at examples of all this, if you re-raise your exception or raise a different exception, any subsequent call to backtrace will trace back to that latest raise. In other words, if you're ever doing a re-raise of an exception, always call backtrace first. Otherwise, you'll lose that original line number. So let's take a look. Close out all these files. Make some room for backtrace. Okay, so proc1 raises no data found. Proc2 calls proc1. Proc3 calls proc2. So let's call proc3 with an unhandled exception. So we're not going to handle the exception. We'll just see what happens when it goes unhandled out to the client. And there you see the error message and the trace back to line 5 of proc1. So this is the information that a user would see if an exception goes unhandled, and that's really critical information. Now I know the error occurred on line 5. I go to my program, line 5, I see what the problem is, and I fix it. But prior to 10.2, if I try to trap that exception inside Plsql, for example, display the error message, display the error stack, whatever the case may be, I would lose that line number. So now what I can do is go back to my program proc3, and I can add a call to format error stack if I'd like to, but most importantly, format error backtrace. And by the way, my apologies, there's actually a typo in the slide. This should be format error backtrace, not format backtrace. My apologies. So let's recreate procedure 3 and call it again. Now I run my code. Of course, the exception is not unhandled because I trapped it. And if I look at my output, I see the error message or the error stack, and here's the backtrace to line 5. So the same information that used to be available only as an unhandled exception is now available inside your Plsql code. This is really fantastic stuff. Again, I encourage you to always call backtrace whenever you're handling an exception, or call a reusable program that does it for you. And I'll talk about that in the best practices video. Now you can decide where you want to call backtrace. One of the nice things about backtrace is that you can call it at any level. For example, this is called at the top level. The exception was raised down in proc1, but no matter where I call backtrace, it'll trace back to the original raise, or the line on which the current exception was raised. Okay, and let's take a look at the re-raise. So proc1 raises no data found, and then re-raises the exception out of the error handler, and proc2 raises value error, and proc3 calls backtrace again. So let's run these different steps. First of all, what I'm going to do is take out the call to backtrace in proc1. So we're simply going to raise the exception again. And when I run this code, here's what I see. Backtrace traces back only to line 9 of proc2. In other words, the fact that the original error was raised on line 5 of proc1 is completely lost, because this raise was executed and no backtrace was called, and this raise was then raised on top of that one. So when the backtrace was called, it can only trace back to this line. And if you want to make sure you don't lose any of that information, you definitely need to call Backtrace before any re-raises occur. So now if I run this again, here's what I see. The first backtrace pointed me back to line 5 of proc 1, which is what I want to know, the original line number. Subsequent calls to Backtrace then trace back to the most recent raise. So if you're using Backtrace, which you definitely should do, make sure it's called before you do any re-raising. And if you want to do parsing of the Backtrace stack, just like I offered a tracing of call stack, the BT package will do that for you. Alrighty, let's draw some conclusions. So whenever you're handling an exception, the most important thing to remember is that Oracle offers a suite of different tools, functions, SQL code, SQL error message, backtrace, call stack, format error stack, to give you generic information about the context of the error, what the error code was, where it occurred in your code, how did you get there in your code. And it's very important that you use that information to write to a log, or you could display it to the user, but that information is usually something that you'd want to put into your log table for your developers to look at later, or the support team. Of course, in addition to that, when you're handling exceptions, you want to be able to grab the information that's local to that program and specific to that application, variables and the state of the application itself. But that's something you have to do manually yourself, which is why it's a good idea to always trap exceptions and handle them in the block in which they occurred. So, next steps. Again, if you haven't done so already, download that demo zip file, run through the different sample code that I offer in this webinar. There are many different scripts to run. Make sure you're extremely familiar and comfortable with the format backtrace, the format call stack, etc., so you can learn how to put them to use in your own applications. And then watch the next webinar in the series, which has to do with continuing past exceptions and the different ways to do that. So thanks very much for joining me, and happy Plsql coding until you visit my next video.